All right, let's continue our adventure on the 2014 released AP Calculus AB exam. This is the last section. It's 4 free response problems where you cannot use your calculator. And I'm just going to go through the first 2 in this video, and then I'll put together a video with a separate video of those last 2 problems. So let's dig in. Looks like you've got 60 minutes for these 4 problems. If you have extra time, you are allowed to go back to the previous section, just you don't have your calculator anymore. So that's one strategy that some students do take advantage of. So this is no calculators. All right, let's look at number 3 here. It says e to the 2x, so f of x equals e to the 2x. That's what we're looking at here. Let R be the region in there. Sounds like we're going to be doing an area, maybe revolving kind of problem, right? First quadrant bounded by the graph that you see there. And the vertical line x equals 1. Notice they gave you this point up here. When 1 goes in, e squared comes out on that function, of course. Write an equation for the line tangent of the graph of f at 1. So looking for this right here. I'm sorry, at x equals 1, that would be up here, of course, at x equals 1, not y equals 1. All right, so we have a point, and that's 1 e squared. So what else do we need? And then we'll have it. We need the slope. We need the slope. You remember that equation, y minus y1 equals m times the quantity x minus x1? All we need is the slope, and we'll be in good shape. So where does the slope come from? The derivative. So the derivative on f of x would be 2 because of the chain, right? Because of the chain, you know that, right? And then you plug 1 in there. F prime of 1 equals 2e squared. So we're ready to write the equation of the line. Y minus e squared equals 2e squared x minus 1. And you can just leave that answer like that, or you can add e squared to the other side if you'd like, and you could do that. All right, so that's the line tangent. Find the area of region R. Well, you want to think about which way do you want to run your rectangles. Are these going to go vertically or horizontally? You can do it both ways, but there's an easier way here, and that is vertically. If you run vertically, you don't have to worry about any sort of subtraction or anything. So we've got the integral from 0 to 1 because we're doing this with dx's as our width on our rectangles, right? So it's always upper function minus lower function, but we only have one upper function. It's that y equals e to the 2x function. So we're going to integrate from 0 to 1 on e to the 2x there, dx. So the area of the region is the integral 0 to 1 e to the 2x. So u would be 2x, du equals 2 dx. So dx is 1/2 du. So this would be the integral of e to the u du, but we're going to have a 1/2 on the outside. And then let's go ahead and change the bounds because it'll make our life easier here. If you plug 0 in here, you get 0. If you plug 1 in, you get 2 out. So now you do the antiderivative, and of course the antiderivative is just e to the u. You evaluate it from 0 to 2, and you get 1/2 times the quantity, e squared, but don't forget, e to the 0 is 1. So you would have minus 1 there. E squared minus 1 in parentheses, all times 1/2. That would be the area of that region. All right, moving right along. Letter C here. The region R forms a base, and then up from the base is going some cross section. So this is not a revolution problem. This is not rotating around one axis or the other. We are going to be having squares that go straight up it says perpendicular to the y-axis. So I always like to try my best to draw these somewhat with perspective here, maybe to give students some help understanding this. So this is sort of shooting up like that, And down here we have another square kind of like that. Right? So these are squares that are going up in a three-dimensional way. So how do you find the area of a square? It's just side squared. Side times side. So if we could figure out this side, then we just square it. That would give us the area. And then, of course, we integrate it over the entire thing. But I want you to notice that in this region right here, we actually just have a box. From 0 to 1 on the y-axis, we just have a box. So we want to keep that in mind. That's 1 by 1 by 1. So this volume of that box is 1. So if you're following me here, we're really just needing to use calculus on this region higher than that. Now, since this is going to be a dy problem, right, our squares are running left or right. This is a dy problem. We have to solve for x up there in the original equation. So the original equation was y equals e to the 2x. So how do you solve for y? Well, you do the natural log on both sides. You get the natural log of y equals 2x. You then divide by 2 or multiply by a half. So x is the same thing as 1/2 natural log of y. So we've solved for x. That means we now know, let me change colors here, might help you out. We know the distance from here to here at any given moment, right? But in order to get the distance from here to here, we would have to subtract 1 minus. So, by the way, in the problem, I didn't read it, it says, but do not evaluate. So that's kind of nice. So we can go ahead and set up our integral. Our integral is going to run from 1, remember they're y numbers, all the way up to e squared. And I just said a moment ago that the width of every single square is actually 1 minus our function up above, which is 1/2 ln y. And then we're going to square that. All right, the volume equals, but do not forget there was this box on the bottom. So we're going to have a 1 plus on the bottom there, and don't forget our dy. And we have our answer, and I'm just checking, and I've got it exactly like they do in the rubric. You've got to have the bounds correctly set up, as well as the integrand in there, and of course the 1 plus out front to get all 4 points on that thing it says. All right. Let's move on to number 4, which is the second problem here in the no calculator section. The continuous function is given above. Now notice that it has some corners. You should really take note of that. The graph of f is given here, consists of 4 line segments. Let g be the function given by this here. So it's got this portion right here. So what is this? This is the area under the curve from -2 to wherever. That's what this represents. And if you go backwards, it'll be negative. And I think they actually try to trick us on that here in a moment. All right, so the first thing is g of 0, to find g of 0. So if you plug, so g of x, g of 0 would be 2 times 0 plus the integral from -2 to 0 on the graph that we look above. So you remember when you first started learning about integrals, you used areas to solve them, and that's what you have to do from here. We're going to go right in here. We have to find that area right there. So that is a trapezoid. So trapezoids, you do base 1 plus base 2, and that's 2, right? This is 1 high, this is 2 high there. All divided by 2 times the height of this thing, which is 2. So that's the way I would do it personally. These 2's cancel, and you end up with 3 as your answer for g of g of 0. Now g of negative 5, I'm going to erase that because now we got to do g of negative 5. G of negative 5 is over here. But notice we're going backwards this time. So g of negative 5 would be 2 times negative 5, that's negative 10, plus the integral from negative 2 to negative 5 f of t. Now, if you want to reverse those bounds, you have to change it to a minus sign. So it wouldn't be a bad idea to actually do that because usually we like to see the smaller number on that lower bound. So you could do that there. So we have negative 10. All right, we have to find the area of this. All right, so how tall is that? That is 4 by 2. So that's got an area of 4. But remember, it's under the x-axis, so it would actually be negative 4. And then this is above the x-axis, and it is a base 2, or I'm sorry, base 1 with a height of 2. So that's a volume of 1, or an area of 1. So we would add 1. So that ends up being negative 3 in there. So negative 10 plus 3 is negative 7. And both of these are the correct answer. So you want to show all your work there. All right, moving on. Find the derivative in terms of f. So let's do that first. G prime, I've got it written down here for you again. G prime of x would be 2 plus, now remember the derivative of an integral is just the original function with the upper bound plugged in, and then sometimes you had to add on a chain, or multiply by a chain, but we don't have a chain here. So that is the problem right there. So then they ask us to find the second derivative. So the second derivative, I would just go ahead and write it, is 0 plus f prime. Oh, how do you find f prime? That is just slope on this graph. So we're going to read the slopes off. That's all we're going to do. So for example, g double prime at, the first one is what, 4? Yeah, so we go to 4. 1, 2, 3, 4 right here. And we figure out this is going down 6 and over 6. Ooh, that sounds like negative 1. So g double prime is negative 1 of 4. Now what about g double prime? This one's easy. At negative 2. Well, what's going on there? Remember we noticed that it had some corners in it? At negative 2, there is no slope, so it does not exist. The derivative does not exist due to a corner at negative 2, 2. You know, I don't know that you necessarily have to give a whole corner information, but hey, why not? And we have 2 more parts here. On what intervals, if any, is the graph of g concave down? Okay, so remember g prime? Well, let's just say this. G double prime, we already found, didn't we? That was just f prime of x. So when are we concave down? When the second derivative is negative, or when the first derivative is decreasing. Now I've got the second derivative. I'm talking about this side right here. So when is the second derivative negative, or the first derivative, meaning this, is decreasing on intervals. Now these are going to be x values from x equals negative 2, that's right here, from here to here, union, and then from here, which is 2, all the way to 8. So that's when this thing is, just check and make sure I got that right, and I did. And they also have here, make sure that you say your reasoning. is G prime is decreasing on intervals. Okay, you could even say, so G is concave down. You don't have to say that, but all right. Letter D. The function h is defined by g of this other function. Find the first derivative of that thing. So h prime of x would be g prime composed of x to the third plus 1, but then multiplied by 3x squared. That's that chain. That's that chain, okay? So g prime, remember up here? Let's go back up here. G prime is 2 plus f of x. So this would be 2 plus f of x to the third plus 1 times 3x squared. Now we are finding h prime of 1. So this would be 2 plus f of 2 times 3. Now f of 2, so our f function, remember, is the graph that we're looking at there, right? Yeah. So we should be able to read that off of there. Equals 2 plus, so f of 2 would be 3 times 3. Now I lost a parenthesis here, so this is important right there. You were probably screaming at your computer right now, right? So there should be parentheses there, which means there should be brackets right there, because all of that represents that g prime of x to the third plus 1. And so we end up getting 15 as our answer. And that's what they have here on the key. All right, make sure you show all your work here, and hopefully you got all this right. All right, I'll put together another video with these last two questions, and that'll wrap it up for this test. Good stuff.